Okay, here we are given the graph of the original and we'll sketch its derivative. So here we go. Look for the easy numbers first, namely the horizontal tangent lines. And as we can see, we have it here, here, and here, right? And as we all know, the slope over there at these 3 points will be 0, meaning that the derivative will be 0 at these 3 points. So I just have to go down and we have the 0. And again, that's the x-axis here. And likewise, this right here will also give us 0 for the derivative. And then likewise, this right here will also give us 0 for the derivative. So we have these 3 points. Then you can do the following. Notice that we actually have 2 points of inflections, namely here and here, right? So if you look for that, you will see this right here, in fact, you actually get the biggest slope from here to here, right? So what you can do is you can estimate that if you say this is like slope 2, maybe, then you just have to go down and you just pick your y value here. Let's say this y value is 2. So 2 for the f prime. And the good thing about this is that notice any point like close to this, let's say right here, this is actually going to be a smaller slope than that. So when you go from here and you go down, it has to be a smaller y value than this. Similarly, if you go at here and you'll see that this right here is actually slightly smaller than that, so you should have a lower y value like that, right? Likewise, for this, in fact, it's the same idea, but this time it's actually negative slope. So you actually have to go down to the negative y value right here, so below the x-axis. And again, remember, maybe this helps if you put on positive derivative and then, negative derivative. Positive f prime and then negative f prime. This right here is negative, so that's why we go below, right? And then of course, if you go right here, this is not as small, not as negative as that. So you actually have to go down. It has to have a higher y value like this. And just continue. And again, you're just like a computer. Pick a point on the curve and then just draw a little tangent segment and compare with other ones that you know already. This right here, it's flatter than that. And it's negative, so you actually go down maybe like this. Right? So that's pretty much the idea. And now, perhaps I'll just come here then. Okay, for this side, if I draw a little tangent segment, maybe like -2, -1, whatsoever, but I will again just line up and then I'll go down. Let's say it's like this. And then if you go right here, you will see that this is actually really downward, right? So you actually have a much smaller y value, so you should have a lower y value right here like this. And if you go to the other side, this right here, maybe like slope 1 or 2, I don't know, like this by estimating, right? But based on this, you can see that at this point, this has a higher slope than that. So when I go down, it has to be a higher y value. So I will actually do like something like this. So that's pretty much the idea. And now, of course, if you connect the dots with a curve, you will see here is my graph. I know, okay? I'm connecting the dots. I am connecting the dots. But anyway, that's pretty much the idea. And notice that the truth is this is a 4th degree polynomial, right? It looks like 1. I don't know what happened after that, but it looks like a 4th degree polynomial. If you differentiate a 4th degree polynomial, you get a cubic. Looks like this. That's it.